All right, thanks everybody for joining this week. We have another talk that's more akin to a tutorial. In fact, I believe this tutorial has been given a couple times before at some of the Internet 2 meetings over the years. So we'd like to continue to build up our library of things that we can share with members of our teams that are new to some of these technologies. So Alan has been very generous with his time today to go through this. And he did send around some instructions for the live demonstration and things that he's going to be doing as a part of this tutorial. So hopefully some people are able to participate with that. So I will turn it over to you, Alan.
All right, thank you. You can hear me, right?
Yes, sir.
We had anybody who went to APAN 50 a couple weeks ago got to witness the guy starting the plenary and talking for about 3 minutes before he realized he was muted. So it always pays to check. Probably aren't very many people who don't know me. And this is the title I chose when Jason asked me to make up a title. So we're going to go with that. And when you shorten lunch and learn to L&L in Hawaii, it has a special meaning. This is the logo of L&L Drive-In, which is actually has some outlets in the mainland US, maybe even in Asia. And while I can't say that this talk is brought to you by L&L, I kind of can because the founder donated $1 million in 2017 to the University of Hawaii. So credit where credit is due. Giving people what they want is a good way to make money. So I want to point out the term IPv6 Solutions because a few years ago in the IPv6 working group, the Internet 2 IPv6 working group, I started to pose the question, and we started to pose the question, we've got all this IPv6 deployed in dual stack, is it really solving any problems? And kind of noticed that a lot of dual stack networks are essentially symbolic victory gardens, and they are an expression of solidarity and alignment, but they don't go very far towards solving problems. And many dual stack networks do not apply operational parity to IPv6. If you look at them, and I'm talking about my own network here, that it's possible for IPv6 to start bit rotting or something goes unreachable for a week.
Hey, Alan, your slides aren't advancing, just as an FYI.
Does it say IPv6 Solutions right now?
It is still the title slide.
No kidding. Well, crap.
There we go. Now you're on number. There you go. Now you're on 2. Okay.
That's the L&L slide. Let me stop. Okay, I'm going to stop the share. I'm going to share the whole screen. No, sorry, not screen 1, screen 2. And then I'm going to make this one bigger. So you see L&L now. Now you see the founder of L&L, right?
Correct, yes.
Okay. All right, so, but IPv6 Solutions is a nod to, although the 15 years of dual stack deployment have been very valuable in terms of amassing operational experience and pushing the evolution of IPv6, it's really time to look at how to use IPv6 to alleviate the effects of IPv4 address depletion, and the effects of dual stack are minimal. They're not. It isn't that there's no effect, but they're minimal. So the inquiry has been, how do we use IPv6 to actually solve problems? So from last evening into this morning, I kind of started channeling Joe St. Sauvier. So I'm just going to have a few really wordy slides and read every word of them. So consider that national, regional, institutional RNE networks and exchange points have a long, stable tradition of providing v6 connectivity, usually as dual stack. Such things as data transfer nodes and measurement nodes and some other things, what we call cyber infrastructure, already support IPv6 and they support it well. IP protocol version is not influential in terms of attainable throughput. You might have to troubleshoot just like you do with v4, but IPv6 can fill the role. And it would be trivial to commit to using IPv6 without the IPv4 in such data movement contexts. It's easy and normal to install and update modern Linux and BSD distros without IPv4. At first I made that line, it's possible, but it's not only possible, it's just normal. The distros do not care if they are connected with only v6. They have a v6 connection and a v6 name server, and you can install Linux, and then you can update it, and it will update itself, and you can operate it. There's no special crutches involved. Most of the remaining problems with transition technologies and residual v4 persist in eyeball edge networks, places where people have smartphones and laptops and desktops where they're viewing content, they're viewing resources. And mostly because those resources are developed by an infinite number of people outside the organization. That's why we have to have special circumstances. And so all the time and money into deploying IPv6 either as dual stack or IPv6 only is going towards those eyeball edge networks. So I'm going to talk about a lot of mitigation strategies exactly for eyeball edge networks, but keep in mind that such things as what we call cyber infrastructure for science are pretty simple. It's pretty simple to move to v6 and just use v6. Also consider that IPv4 is doomed. If you need me to say it out loud, IPv4 numbering is based on counting how many addresses one needs, and the addresses are running out. Even if you're using RFC 1918 private addresses behind a NAT, you can assign them in chunks of 16 million at a time at the most. IPv6 addressing has nothing to do with counting addresses. We superimpose that philosophy onto it because we come from a counting tradition, but the fact of the matter is that IPv6 addressing is a canvas upon which you paint a numbering scheme. It's really useful to start thinking of it differently. Common addressing schemes have been rewritten and redeployed from the ITF several times, and yet the older addressing mechanisms that we started with continue to work. So there's this modularity in IPv6 addressing and this flexibility in IPv6 addressing that doesn't really get justice if you consider it like a counted address scheme like IPv4. Also, IPv6 is mature after 15 years of operational experience in dual stack networks and considerable evolution from lessons learned. The ITF has made changes and they have been implemented by OS vendors. Operating an IPv6 network is different in numerous ways, and building experience is critical. So if you're not doing any IPv6, you're not doing yourself the favor of giving yourself operational experience before the time when it starts to become more urgent. You can either do it in your spare time, or you can bear down and try to do it all at once when the time comes. Enabling IPv6 deployment isn't about readiness or feasibility anymore. It's about effecting priorities and policies in network operations and security. It's about getting everyone on a page and moving forward. So also I use the phrase simplify your life, and I almost regret having done that, but keep in mind that purpose-built RNE infrastructure, it really is pretty simple to move to v6, even though I'm going to talk about some essentially complicated things. And running IPv6 networks is simple. Maintaining measures to perpetuate IPv4 is complicated. And many of the things like DNS64 and NAT64 are most important in bringing external content to end users, which I kind of already said. I tried to limit the repetition. Of course, maybe I'm trying to brainwash you. Repetition is good then. So this picture is important because there are all these measures of IPv6 deployment and penetration and usage that refer to what percentage of the total internet has moved to or has offered IPv6 connectivity and what % of the total internet's resources are available over IPv6. But consider that we don't use the resources on the global internet equally across the whole set of resources. We use certain resources a lot more than we do others. So on the UH Manoa wireless, UH Manoa is our largest campus at the University of Hawaii system. In November of 2019, I normally update this slide before a talk, but of course right now the campus is deserted and there's not much going on. Normally there are about 15,000 users on this wireless, and right now there are about 2,000. This is from November 2019, and if you compare IPv4 in green to IPv6 in green to IPv4 in red, by flows, V6 is about 34%. By packets, it's about 59%. By bits, it's about 53%. And the obvious answer to why V6 flows are packet and bit rich is probably that things like YouTube and Netflix dominate V6 use and really kind of pump the numbers. But it's interesting to see that a significant proportion of our users' resources, the resources our users access, are gotten over V6. So also the term IPv6 Only Network. I didn't make that term up. At the beginning, I kind of thought maybe I had, but as I went out into the world and searched for it, I found that it was a common idea had by many people at the same time. And so what an IPv6 only network is a network where local gateway routes only V6 and no IPv4. Most routers and infrastructure only have IPv6 addresses on their interfaces and on their management. IPv4 is offered to users as a service over IPv6. This tutorial, I was tempted to go through and make it all reword everything to make it look like the tutorial never existed, but I didn't do that, so just understand. And I'm not really going to reference the hands-on portion during the talk, but we'll just talk about it. But this tutorial affects v4 as a service with NAT64 464X-Late. Although the network may offer v4 addresses to users, any IPv4 on the local wire is translated to v6 before it reaches the local gateway. So even though you may assign v4 addresses, or the individual devices may make up their own v4 addresses, they will not be routed through the local gateway. They don't get off the local wire. The value of v6 only is operational simplicity, single stack support. You only need the resources for one route table and one address translation table. We had a cycle of, when we deployed dual stack in 2008, we had a string of routers on a GigE backbone on the island of Hawaii, which was composed of Cisco 3700s, and it worked great until we did dual stack, and then it was out of memory and out of route tables storage, and so we had to upgrade. So it's not really an oft-cited thing, and maybe it isn't even a problem in 2020, but it does affect. It is a financial and real thing to consider that routers need more resources to run dual stack. Also security, you reduce configuration complexity with a single stack, and you only have to do things once. All the v4 policy is concentrated in one place at the NAT. It provides direct non-NAT connectivity to v6 connected resources, which is a larger proportion of the traffic than you might think. And commitment to IPv4 deployment gets shallower rather than deeper. Also, v6 only limits the deployment of real v4 addresses so that they may be used efficiently. IPv4 addresses can only become more costly. Plan to divest before the market tanks. That's, well, we should have a betting pool for that. v4 addresses and NAT pools will serve at least, this is a personal estimate, about 3,200 times as many flows per IP number as individually assigned end user addresses. You make a lot better use of an address by putting it in a NAT pool. And this is important if you're running out of addresses. If you don't have another block to assign it to that next subnet, you should really think about doing v6 only. Or perhaps dual stack as an interim measure. So IPv4 as a service refers to providing v4 content to a v6 only host, generally treated as a futuristic concept, but when should we decide that it's time to push IPv4 into as a service? Well, how about now? There's actually one commercial vendor, retivia.net. You can go see, there's a link right there to go see the talk by Lee Howard, who's the founder of Retivia, about Retivia and the stuff that they're doing in the IPv6 working group box folder. And it was an interesting talk, I must say. He gave some perspective that you don't often hear. So go check that out. So in the tutorial, experiment one was the v6 only network. And so what we did was we supplied v6 connectivity to the clients in the room via Wi-Fi AP. And so they have v6 connectivity, they have addressing, and they have access to a DNS server, which we supplied in two ways, one by DHCP and one by our DNSS from the router advertisements. And so given that, it's kind of interesting to see how sparse the content is. If you want to try this at home, what you have to do is, step one is have v6 connectivity at home. If you already have native connectivity, you're all set. I'll leave you to figure out whether you want to set up an HE tunnel or something and go through all those hoops. Then you have to make sure that Google's open recursive resolvers for DNS. These are not NAT64 resolvers, they're regular resolvers. Put those in as your DNS servers and then turn off IPv4. And it's kind of interesting. Don't do it now. It's kind of interesting. These are from yesterday. I put NDSU in bold because Bruce Curtis just told us on the v6 working group call yesterday morning that North Dakota State has a v6 enabled website. Ooh, and along with some other, I came up with some other universities also. I mean, they're not the first or anything, but we like to acknowledge them. I was going to go through all of the cabinet level federal government departments, but I kind of got tired of doing it, and they were all positives. I noticed that IRS and TurboTax are both there, so maybe you can try to do your taxes over v6 only next year. All of the usual suspects. You might find it interesting, or you may not. So why we chose DNS64 and NAT64, you're not supposed to say 64, I don't care. Because it's the most implemented mature relevant scheme, it does not require you to alter end user devices. It uses regular commodity hardware. There are implementations of each piece available from multiple sources, including open sourcey Linuxy stuff. It collects globally routable v4 addresses in one place. As a record of success, there's another talk in the v6 working group box folder by Stefan Lagerholm about IPv6 only network, T-Mobile's IPv6 only network in North America. And although NAT64 holds state, it doesn't affect network topology. If you want to leave it out, you stop driving traffic to it. So to clear something up, if you go out and start trying to research a NAT64, if you find a page by myself or Jordi Pale Martinez, you're probably on the right track. But there are a lot of other pages by individuals who tried it at home, and they set up and they'll have a drawing that shows it like it's an inline box, and it's not an inline box. It sits on your network and you drive traffic to it. It's routed to like any other service. And so it's there and you don't use it until you either use the services of a DNS64 or you manually drive traffic to it by coding addresses manually. DNS64, it comes as a feature in bind. I think it was in bind 8. It is certainly in bind 9. It assumes the existence of a compatible v6 to v4 translator, which in our case, in most cases, means NAT64. When it gets a request to resolve a name, it has no quad A record. It synthesizes a quad A record, which with its local prefix, and essentially reinterprets a v4 address to present it as a v6 address. It theoretically breaks DNSSEC, or I should say, a lot of people enjoy saying that it breaks DNSSEC, but all the pieces are there. This is a reversible, deterministic process for address reinterpretation, and you could totally do validation on it if you wanted to, or if you designed it that way. So in practice, if you have a bind DNS service, your named.conf somewhere has an option stanza in there, and in the option stanza you put this substanza DNS64 with the prefix, etc. Zooming in on that, you have DNS64, the prefix. You could have multiple of these with different prefixes, and then the client item says which clients shall receive this synthesis from this name server. So you can give it a group of clients. If the client is from that group, it'll get the synthesis. If the client's from a different group that's defined in a different DNS64 stanza, it'll get that synthesis. If it's not in either DNS64 stanza, it will get no synthesis. And more stuff to read later. DNS64 can live on your main recursive server or on a caching forwarding server near your v6 only network. You can serve it from both v6 and v4 addresses, and why that makes sense I'll address in a little bit. You can put a DNS server on a v6 only network, but if it has no v4 connectivity, it needs to forward to a v4 connected server because many domains don't have IPv6 connected name servers. I'll let you read that again if you don't understand, but I mean when I give you the slides later. So DNS64 does provide A records. It acts just like DNS. It just fills in a missing quad A record. So resolver behavior, happiness-oriented browsers and legacy OSs and et cetera may choose A records when presented with both. So part of the goal of DNS64 is to drive more traffic to v6, but the clients don't always participate. So A record suppression is a discussion that's going on, and whether or not it's not a simple thing. I wouldn't just I wouldn't figure out how to do it wholesale. There isn't a switch for it. You have to pretty much kludge it in. On to NAT64. So NAT64, when paired with DNS64, is NAT that shrinks rather than NAT that grows. It's better than NAT44, or what we call NAT. For various reasons, it begins as an enhancement to a v6 network. The more v6 grows, the less NAT you have to do. Promoting native v6 with DNS64 reduces the use of NAT v4 address port space. And this is a critical difference between NAT64 and dual stack with NAT44, because if you're not promoting more use of v6, NAT64 essentially has parity with regular NAT on a dual stack network with regular NAT. NAT64 presence gives you a way to manually specify v4 target to a v6 only host. It's actually pretty cheap and easy to set up a NAT64 in your network, and that gives you the ability, if you have a v6 only connected host, to reach v4 resources just by manually encoding addresses with that prefix in front of them. And God bless whoever came up with the v6 prefix followed by the dotted quad v4 address notation, because it works in pretty much all contexts and it makes things a lot easier. As v4 addresses become more expensive and scarce, Providing native v4 addresses on a per interface assignments becomes unthinkable. I have better stuff about that later. NAT64 accepts packets destined for translation prefix destinations and translates them to v4. The well-known is 64:FF9B. You can use any /96 for your NAT64 prefix. It accepts response packets from v4 destinations, sends them to the initiator, the v6 host, via the translation prefix source address. Can I move the? Yes, I can. Okay. Your faces were on top of part of my slide, and I couldn't read my own slides, and then I'm lost. So stateless NAT64, I call it stateless NAT64 to kind of tie it in, but most of the time it's called SIIT, which is stateless IP and ICMP translation with something address mapping, blah, blah, blah. Stateless one-to-one address mapping appropriate for making IPv4 servers look like they're doing IPv6. It's probably just smarter and easier to put v6 on the servers, but it probably also has uses for some time to come for such things like long life IoT, HVAC, power, telecom management and stuff. Stateful NAT64 is the one that we usually mean when we say NAT64. It has an end-to-one NAT providing IPv4 as a service on a v6 only network. Uses address mappings in the form of blah. You take the quadded dotted quad, and you tack it on the end of the prefix, and you have an address. So previous incarnations of this talk, this is a 90-minute talk, and I'm trying to fit it into an hour. So I cut some slides. There is stuff about making your Cisco IOS do NAT64 in previous slide decks. And actually, there's video on YouTube. Just search for Richard Machita's posting of our 2017 stuff between me and Jeff Harrington doing a workshop in San Francisco. And in there, I discuss iOS. And it's also in the previous slides. I probably just spent about the same amount of time explaining that the slide wasn't there. So stateful NAT64 on Linux with Jool 4.0. Jool is pronounced like the English jewel. It is a Mayan word, not a Spanish word, so don't say hool. I have a setup of Jool in Ubuntu 16.18 and Raspbian 8 to good effect. It is the only Linux-based SIIT NAT64 solution I've tried, and it's currently actively developed and has some really smart people involved in Mexico. I think most of the developers are actually in Mexico, although there may be other team members outside of Mexico. And it's kind of best of breed. There's some other things like Tega, which is in Userspace, and some other things which are incomplete, but Jool tends to be the real full-featured serious NAT64 implementation for Linux. Irrelevant. So I represent this as rc.local. You can put it in whatever systemd abomination file you want to, but you go through and you turn off some offloading stuff, and you set up the pool, and in syscontrol.conf you make sure forwarding is on, and for both v4 and v6 you change the ephemeral port ranges to maximize the number of ports that are available for NAT translation, which is an interesting thing, because these little Linux boxes are not going to do very much, and then they're not doing web servers, they're not doing other services. So the ephemeral port range that's there by default is tens of thousands of ports, and it's really unnecessary. And I've had no problem choking it down to about 100 ephemeral ports available. In the interfaces file on the Debian Ubuntu side, the Etc network interfaces, of course, now Ubuntu uses NetPlan, and I've never done it with NetPlan, but this is how it looks in Debian interfaces. You have to set up each of the pool addresses as a sub interface so that the network will find them reachable. And then you use the Jool command, which is a little confusing. There's a module. You mod probe Jool to get things started, and then you use the Jool Userspace command to monitor stuff. And you can see that the pool is there, etc. So once everything's going, I put a static on the router pointing to the NAT64, and I export an OSPF. And so any IPv6 connected host, you can ping stuff by doing ping6 with the prefix, the dotted quad for the v4, and then just try stuff. So it's actually pretty easy to hand synthesize NAT64 addresses. So experiment 2 was, we take that v6 only connection network and we add DNS64 NAT64 to it, and this really changes your view of the internet. This goes from having to find sites that do v6 only to trying to find sites that do not work with NAT64 or DNS64. And the sites, I think I have a pathology size, but the sites are few and far between. In fact, Chris Zane has messaged me when he came on. He's actually using Zoom through DNS64, NAT64 with absolutely no v4 cleanup on the wire. So just DNS64, NAT64 works with Zoom. It did not in 2017, but in 2020 it does. So you can have a v6 only connected host through a NAT64, DNS64 network now and do Zoom. It's more versatile than the first experiment, but eventually you find something that does not work. And I probably should have deleted this slide, but that address is actually present. You can go to it if you want to. And the whole point of that page, which I will show you in a minute, is, there it is. That's the former version of it. So it has a picture of an apple, which is referenced in its URL in the image tag by a v4 literal, and it's got a picture of an orange, which is referenced in the image tag by a DNS name. And if you just use DNS64, NAT64, logically you would see only an orange. But you find that some devices get the apple, even when there's no v4. So it's got an image by a v4 literal, which means it hands you a v4 numeric address from the HTML code. And so then your machine is tasked with looking up and fetching that picture from that v4 address. But your device has no v4 connectivity, and DNS64 can't help you. So how does it do it? It's because some operating systems or browsers, notably Android and Safari under iOS and Mac OS, will do internal, what they call client LAT, which means when you ask, it sees it has v6 only connectivity. You ask it for a v6 or for a v4 resource, and it'll say, oh, well, that's not going to work. So it will automatically do NAT46 and send the packet to the NAT64. And when you put 46 and 64 together, you have 44. This is some sort of transverse mitigated Boolean logic I just made up. And voila, there's an apple. If you don't understand what I'm talking about, put it in the questions. So Windows 10 has this baked in, but it's not turned on unless there's a local mobile hardware like an LTE interface. You've probably already read the slide. There are options for being examined in the IETF to inform in-hosts of IPv6 only presence. And they're working on such things as v6 router advertisements and DHCP v4 having an option to say, oh, by the way, we prefer you to be v6 only on this network. And that would clear up several operational issues with NAT64 networks. Also getting Windows to turn on their baked in CLAT when it's on an Ethernet or a Wi-Fi network. So the client state at this point is the client still only has a v6 address, no v4 address. The NAT64 is synthesizing responses to reach v4 only targets through NAT64. And a majority of internet resources are now reachable and usable. 464X Lite, another RFC. It's a superset of NAT64, and it can be a transition strategy all in itself. It uses a simple form of SIIT-NAT46 to clean up residual v4 requests from software such as hard-coded v4 literals and send them to NAT64. It employs two pieces, CLAT, which I already mentioned, and PLAT, which is a provider LAT, which will usually be a NAT64. I don't know why I say usually, it always is a NAT64. It takes stray v4 packets, translates them and sends them to the NAT64. There are three styles. One is bump in the wire, meaning there's a local wire device that does the duty. The IPv6 Solutions tutorials that I did at Tech Exchange and Apricot and APAN use that. They provide a device on the wire that hands out v4 addresses and then becomes a router and then does NAT46 in order to send to the NAT64. Bump in the host, meaning it's a feature in the end host, or bump in the browser. You could probably put bumps and other things, but there it is. People don't see 464 CLAT. I guess I kind of started using it because it makes sense to me. I do not need any royalties. So this is to set up, if you put your small device or VM or whatever on a local v6 only wire to hand out v4 addresses and enable v4 cleanup. For those devices that don't have internal CLAT, this can make the last of the things, it can deliver the last of the things through the chain to the NAT64, where they'll be made into v4 again. And this is just some actual typing in. I don't need to read that. DHCPD is how I assign the v4 addresses. We do not assign DNS servers, although it's interesting to consider if you assign a name server and make it the DNS64, then you've got a solution to the Android problem, because let's see if I'm talking into a slide that's next now. So anyway, but I'll hopefully address that a little more. And the Android problem in question is Android does not do DHCP6. It only does Slack. And Slack that provides DNS addresses is actually pretty well figured out, but it's also not in much of the hardware, the router hardware that we all have deployed. So it still becomes sort of an issue. Experiment 3 was to make this little device that hands out v4 addresses and does NAT46 to send them over to the NAT64. There's a map of it in pretty colors. And you can see, I don't know if you can see my pointer, but this thing here is what we're talking about. So as I do have a slide, support for RDNSS, that is the specifying of DNS servers via v6 router advertisements is somewhat limited. Support is not, I mean, if you are buying all new routers today and all deploying them tomorrow, you probably can deploy RDNSS capable RAs pretty easily, but that's not what we have. We have like 5-year life cycle routers sitting on networks all over the place, and a lot of them are just not ready. Cisco is actually offering such features only in iOS XE, last I looked. So your shameful 6500 platforms and your other platforms are probably never going to do this stuff, although you're going to replace those sometime soon anyway. There are some similar constraints in Juniper. So if you're in the CLAT for stray IPv4 literal business anyway, you may as well put the forwarding resolver to DNS64 on the CLAT, meaning that now both v4 only devices will be able to get full connectivity and essentially do 464x late on the v6 only wire. And Android devices no longer need to hear a DNS server from the router, because they get it from the DHCP4. Did I already address this? Yeah. So yeah. So several common OSs handle v4 requests by NAT460 them: Android, macOS, Safari, iOS. I promised myself I would just read the slides and not talk ahead, but you know, I'm kind of addicted to it. So NAT64 Lifestyle, actually, if you can put a NAT64 on your network today at a low, low price. Just call now. And it has immediate benefits, because you can have a v6 only host that you can reach. You can SSH to, you can ping, you can, you know, you can grab web pages, you can set up VPN services. Anything that will accept a v6 address will accept a hand synthesized NAT64 address. So if you're setting up your laptop to be v6 only, you can, and you've got an app that's being a little bit, that takes a v6 address but is being a little bit squirrely about working with NAT64, you can hand code the address in there and make it work. So yeah, that's enough of that talking. So some pathologies with NAT64 and reasons why we do the on-wire CLAP that I just talked about. IPsec uses NAT to traverse NAT44. It doesn't seem to work with NAT64. I have looked for a solution for this and not found one. I think the solution is probably to stop doing IPsec, to stop doing it on IPv4. And I'll just go ahead with the Freudian slip of stop doing IPsec, because I've been the IPsec guy for 20 some years now, and I really have grown to loathe it. It's after certificate infrastructure, it's kind of the worst implementation of a thing I think I've ever seen, and actually in concert with certificate infrastructure. So IPv4 numeric addresses hard-coded in software, which used to be the case in Zoom, is still the case in Skype and various other stuff, or in HTML in Pages or JavaScript in Pages. They put numeric addresses in there, and that breaks NAT64. One of the particularly galling ones, or I don't know, you have to give them extra half credit, is dual stack hosts with quad A records, which point to non-working v6 interfaces or non-reachable v6 interfaces. So if somebody was inspired to go out and set up their host dual stack, and then a year later, after a reboot and upgrade, and somebody quit or whatever, it's no longer reachable, and that quad A record is still there. And certain fragmentation scenarios. You can go to jool.mx and read all about fragmentation stuff in NAT64. I haven't mentioned, strangely enough, I lived in a NAT64, DNS64 context with my work machine in my cubicle for 3 years, using that as my exclusive connection to the internet. And I never, not once, confirmed that I was having a NAT64 problem. Of course, I had problems, but those of you who did v4 only during the same time also had problems. And I assert that there's probably problem parity between the two scenarios. So worth mentioning. It's probably always better when you find yourself grousing about whether or not your NAT64 works well. It's probably better to do v6 anyway. And why do we have v4 only resources at all? Because some group does not prioritize v4 deployment. There's a little red flag by that one. Because our deployment is a mid-swing, perfectly reasonable. Because equipment is old and cannot do IPv6, that's actually perfectly reasonable with long life IoT stuff that just gets stuck and there's no upgrade. So there's always going to be some cleanup on v6, or always in the terms of our lifetime. And because the cloud provider sort of supports IPv6, whether it be Amazon or Google or Azure or Nautilus. So, but it's really time to embrace and move forward and work through those red flags. Support in commercial equipment for NAT64, iOS XE, as I mentioned, Cisco ASA or whatever it's called these days, Juniper routers, Microsoft Forefront, blah blah blah, Palo Alto. We have Palo Alto devices, and we've I think Chris kind of dabbled with NAT64 on there, A10 networks and F5, and we had some slides in previous presentations from Brady at the University of Michigan, Mark Belushian, who's retired from University of UC Santa Cruz, Virginia Tech Transportation Institute, which Clark is on the call. Ask him plenty of questions instead of me, and us guys, where we did a couple of different things. We actually originally started doing NAT64 with our ASR 1000, but then somebody needed an ASR 1000 to do other stuff somewhere, and now we're just simply a Jool shop, as it were. Some acknowledgements, which I just kind of just said, but these are people who have contributed to the development of the tutorial and slide set, which I'm presenting for like the 9th time now. Some resources, come back and read about later things. You can go find the YouTube video from Apricot. There's also one from Tech Exchange 2017. Jordy's talks from Apricot in 2019, February, are there. He did a 2-parter, 2 days in a row about IPv4 as a service. Go to the V6 working group box directory, join the V6 working group, send me an email unless I have a slide telling you how to do it. Probably the best resource for NAT64 SIT 464X-Late is the Jool.mx website, which is all in English, should you wonder. I don't think there's any Spanish there. Also, you go to that link and it will lead you to a Google Doc, which I wrote about how to build an IPv6 only network with DNS64, NAT64, and 464X-Late. So a lot of specifics, and I tried to be complete. As I said, it references Debian with etc. network interfaces instead of NetPlan on Ubuntu, but or sysconfig network scripts on CentOS or something. But you can probably interpolate and extrapolate. It seems like the slide's not advancing, so that must be the last slide. Have we accumulated any questions?
Just Clark being a little bit of a smart guy there. So I say you throw a couple questions at him and have him answer.
Yeah. Okay. Well, let me see. What did Clark say? Yeah. What is transverse Boolean logic? I don't know. We just invented it. Sorry. Oh yeah. Okay. So all right. Well.
Well, here we go. So Joe Breen would like to know, what performance impacts have you seen with NAT64?
I have not noticed. There's no attention getting performance impacts in NAT64. It's actually, it's limited by the interfaces on the NAT64 box. The Jool guys, right around the time I was originally doing this, had access to a Cisco T-Rex testing, and they did extensive testing on Jool 3.5, which is referenced in the slide, and found that it performed actually very, very well. Jool 4.0 probably performs better because it's more integrated into the kernel and stuff, which I've read about, but it's been some time ago. So it has a pretty good performance pedigree. It also has clustering technology built into Jool 4.0. You can set up multiple NAT64s and they will sync tables with each other. They'll sync state so that if you lose one, you don't lose the connection for all of its clients. So stuff like that. So Jool is looking at performance, and they're looking at scale, and they're looking at availability. I suggest you check out their website.
Okay, and we had another question here. IPv4 and IPv6 have been running in parallel for more than a decade. What is your best estimate when IPv4 will actually disappear from the network landscape?
It will disappear shortly after it becomes less preferable, or sometime after it becomes less preferable. It's not even that relevant a question. We're going to be dealing with IPv4 at various scales for some time, but the question is, how do you push v6 deployment, and v6? How do you depend more and more on v6 and reduce your dependence on IPv4 so that IPv4 becomes less of an issue? So when is it going to disappear? Probably shortly before we move to IP version 7 or after. It's not really a question we seek the answer to.
I think the other thing, at least in my experience, since we've all been working from home, is that I've been sort of watching my monitoring data, and there's been just this steady increase of v6 connectivity on my home network connection, only because things have migrated that way. So
Right.
it really is sort of this opportunistic thing where, as it becomes harder and harder to operate things, v4 only, things go to v6, and then they gravitate there as long as they work seamlessly. For reasons that you stated, as devices become smarter and you don't have to put in the special tooling, they just sort of go that way.
Yep. I want to show you, if you look at this as the Google IPv6 adoption graph, and notice that in the last week of every year since 2013, there's this lift, right? So it shows v6 adoption going approximately linearly from left to right. It shows the scribble, which is a periodic week cycle where the high point is people being at home because residential networks have more IPv6, and the low is people being at work because commercial enterprises have less IPv6. And during the last week of the year, of course, the holidays, and less people are going to work, so there's this lift in IPv6 adoption. So now, if we zoom into the, let's take from Christmas and the holidays 2019, there's the holiday lift, and then the pandemic, the lift occurs in mid-March, and then it just never comes back. Plus the peaks of the v6 usage actually increased by about 3% of the whole, another 3% of the whole during the pandemic work from home period. So it's really interesting to see how it's affecting how much v6 is being used in the world. I took this slide out because I didn't want to, I thought I would be over time, but there it is. So I'll stop sharing.
All right, well, I think we're out of questions. So thanks for going through all of this. Certainly a lot of this stuff is a little bit more than basic, but this is stuff that I think we're all going to have to know how to do eventually if we get back to our campuses and we have the ability to do so, of course. But knowing how it works and being able to deal with it is an important thing. So for those that are still on the call, next week it's going to be George Robb and Charlie Shiflett from ESNet's, and they were going to be talking about DTN design. ESNet's about to roll out a new reference implementation, so hopefully everybody can join that. We'll send out the information on the mailing list. So hope everybody has a good weekend, and thanks again, Alan.
All right, thanks, Jason.